Hey everyone, we're about to start speaking.
Hi everyone, I'm Gabriella and this is Sage. We're a small but mighty team of 2 working on Ceph product security at IBM, and today we'll share some of the ways we're working to make our security processes more scalable, sustainable, and easier to maintain. We'll start by looking at the process we carried over from Red Hat when we moved to IBM, our old process, and the challenges we faced with it before diving into how we've evolved and continue to evolve our processes at IBM.
Hi everybody, I'm Sage McTaggart. I'm a senior security architect at IBM who's passionate about computer security, especially when it intersects with theory and formal languages and storage systems like Ceph. My work at IBM focuses on everything from dependency upgrades to improving architecture so that vulnerabilities, when they're found, can't be exploited. I also have a strong interest in quantum computing and hope to see Ceph implement more quantum-resistant algorithms. In my free time, I love to volunteer and hike with my dog. I'm training my new kitten to be an adventure cat on hikes as well.
Hi again, I'm Gabriella again. I joined IBM Storage Ceph's product security team last year after working on a few different roles like lab migration and program management following my time as a software engineer intern for the Ceph build team. I mainly work on incident response and vulnerability management, but I'm eager to keep learning and developing my skills so that we can continue making Ceph even stronger and more secure. I graduated from Boston University in 2022, and in my free time, enjoy exploring my hometown of New York City and eating sweets. This is my first ever Cephalicon, so I'm really excited to be here and to share some of the work that Sage and I have done together. Before diving into the details, we want to give a little background on the kind of process we brought with us to IBM, how it structured our work, and why we realized where there were areas that could be improved. We were following a sort of circular waterfall approach modeled after Red Hat's incident response plan, where each stage had defined checkpoints that had to be completed before moving on to the next. This included mandatory follow-up at each stage to make sure nothing was overlooked. But despite the structured workflow, we still had gaps. There was no formal verification of upstream or even cross-Z-stream fixes. Although upstream bug resolution happened, it often got lost in the weeds, and downstream fixes weren't always correctly propagated or consistently propagated back upstream. This created coordination challenges between the two. So while this process gave us some level of organization, it was still difficult to maintain and highlighted where our workflow needed improvement. As we continued working at IBM, these pain points became even clearer. Let's walk through some of the key challenges that we faced. First, there was no formal documentation for how bug fixes were handled. Everything relied on individual engineers to track and follow through, which unfortunately oftentimes led to delays or lost fixes. At one point, we had 700 bugs marked as will not fix, while many others continued to take significant time to resolve. Next, our remediation timelines were treated kind of like guidelines. There wasn't much accountability or urgency to address these issues. Following that, handling Ceph-specific CVEs was relatively straightforward since Ceph is our core product, but it didn't scale when we expanded to broader dependency scanning. And some newer CVEs didn't even affect our older dependencies because the dependencies were so out of date. So we were spending time reviewing CVEs that didn't apply. Overall, our process was very manual with very limited scalability. That's what really motivated us to step back and rethink our approach. As Sage likes to say, it felt a lot like herding cats. The manual coordination for getting a fix out worked fine when we only had 1 or 2 CVEs per year, but it didn't scale well when we were dealing with hundreds of vulnerabilities. Dependencies like Grafana have many potential CVEs and need regular updates. Even if a vulnerability wasn't directly exploitable, it still had to be remediated. All of this meant following up with individual engineers repeatedly, almost as if every issue was a complex vulnerability. We had to track each release manually, and it certainly wasn't an agile process. But the challenge didn't stop there. Another major factor is the growing reliance on automated scanners, which bring their own set of challenges with how we identify and respond to vulnerabilities. These tools can flag hundreds or even tens of thousands of potential issues by cross-referencing dependencies based on text matching. Many of these are false positives, especially when we write our own patches instead of updating a version. For example, in one scan, we saw 20,000 vulnerabilities, the vast majority of which were inapplicable. At the same time, Ceph users want clean scans. But we simply can't manually review thousands of findings, especially just between the two of us. Scanners are useful for finding what needs remediation, and just as scanning is automated, we want to move toward automated responses as well. And with that, I'll turn things over to Sage.
One thing I'd like to really note is throughout this process, we have to prioritize CVEs differently. In the past, we did it solely by severity. You can see here from low to moderate, high, critical, unless it was a newsworthy incident. At IBM, we're mandated to remediate all CVEs, with rare exceptions for will not fix. At the same time, an exploitable CVE needs to be treated differently and prioritized differently than dependency upgrades that ought to be as routine as possible. So of course, we still use severity as one metric to prioritize what to fix ASAP, but now we also use affected versus vulnerable, with exploitable CVs taking higher priority. These are ones that actually have exploits where there's a proof of concept attack or one has been done successfully. Now, we still aim to fix all within our fixed timeline, but we're trying to put the effort on ones that pose an actual or hypothetical risk to Ceph users and use secure architectural designs to reduce the risk of any CVE being exploited while we prepare routine fixes. Via this method, we have prevented any releases from being held up by unwarranted minor security vulnerabilities and kept things a little bit more on track. One other challenge that we have is that RHEL is the backbone of downstream Ceph containers. Now, we could have a whole debate about RHEL versus Ubuntu versus CentOS, Rocky Linux, any other Linux distro, but the thing is, these are all mature open source projects in their own right. They have their own bug fix policies. And because we build containers based off the distro, scanners will detect those vulnerabilities. This is a pretty easy fix. It's usually a matter of a simple respin and release if the fix exists, but we have to wait for the fix to be executed. And this cuts into our timeline to fix. And we can't just wave a magic wand for our metrics to be nicer. So we've had to improve our process. Now we're still using a stage process, but with clarity and work defined for each stage. One key process improvement we've done already is to limit the scope per person per stage. We're also focusing our coordination efforts, not on following up with individual professional engineers, but by tracking the bugs across 3 different systems when needed. We're also going through our upstream backlog and are actively working this process to improve it. One thing I'd like to just make note of is this process is a work in progress as well and will continue to improve as we work on it. So I'm going to go over each stage now, and our first stage consists of what was the entirety of the PCERT role at Red Hat. So this stage is called notification and triage, and in it we review the reports, we confirm them, we determine if we could potentially be affected with the limited confirmation of scanner results, such as by seeing if we actually use a dependency by that name from the scan results. And then we're now coordinating different trackers, upstream, Red Hat, and IBM, and a GitHub advisory when it impacts Ceph itself. Our next stage is called assessment and coordination. Here is one where our role has expanded considerably. Now, we determine if we're actually using an affected version of an affected dependency. Do we use a version that is affected by the CVE? Now we find the correct engineer and team to fix it. We work with the build team for respins as needed, and we're also now communicating with Ceph leadership about critical and high CVEs to ensure that they get fixed. We enforce separations of duty here by letting the engineer in charge of the fix be in charge of moving the bug to the correct release to have the fix. We know fixes sometimes take time. It's on engineering to figure out when the fix will be done. We can give our guidance and our timelines, but they have to move the bugs and be in charge of it. And you can see we label each here by role: engineering, QA, build team, different teams within security, and that way we enforce separation of duties. Now our next stage, remediation and release, is largely similar to how it's been going for a long time. We have our engineer edit the code, build team rebuilds, QA tests, and we confirm and unembargo when the release is ready. We have a really core goal of not holding up releases for minor dependency upgrades, holding off a release for severe or critical CVEs, not a routine dependency upgrade, which we want to make as routine as possible. Now our final stage, recovery and closure, is similar to before, except now we get to publish in up to 3 places: IBM, Red Hat Errata, and upstream advisories such as GitHub. We have to ensure also that it's fixed in multiple releases across all Z streams, across all branches. And we're doing that, but it's more coordination in this stage, but the process itself is very similar to how it's been going in the past. So to improve our process further, we started documenting our process to see where we were getting stuck. We started tracking why bugs are overdue, and we found the vast majority are blocked by upstream projects that are not Ceph. For example, RHEL, Grafana. If they have a vulnerability, they have to fix it before we can pull in their fix. Now, our engineers do the best that they can, and they're a fantastic team, but they cannot fix all open source bugs in the entire open source ecosystem, unfortunately. So we're trying to treat these as routine as possible and do automatic dependency upgrades when possible. We're trying to automate our scanner responses, and our core goal of avoiding release delays for these routine dependency upgrades has been achieved. Although there's sometimes delays, it's not usually due to these more minor CVEs, and instead we're following this process of fixing them in the next reasonable release for engineering. One thing that we also found upon our move to IBM is that there was no documentation of our fixed processes and steps for security. We have plenty of Red Hat documentation and some limited upstream documentation on how to report vulnerabilities, and it was all oftentimes outdated. We definitely didn't have a clear separation of scope and duties. So we've started that process at IBM. Unfortunately, the Lighthouse link in this slide is on the VPN, and we're working on a public version for upstream for this process to share with the upstream community. We really look forward to working with the upstream Ceph community to improve our processes, especially of embargoed bugs, to improve both security and speed of fixes. And we're going through a very similar process with Rook right now. We're working with them on a CVE example that will be discussed in future talks. And just in general, we're finding that documenting our process is really helping us find what we need to improve. So I want to go over a little bit about how we're tracking dependencies now and how we're discovering what needs to get updated. We use many different scanners at IBM. We use Twistlock, MEN, SonarCube, plenty more. We've used Red Hat internal tools, IBM pen tests, upstream pen tests, and even tools like Dependabot and tons of things within upstream Ceph to tell us where vulnerabilities can be found. Now, other than the pen tests, they primarily focus on identifying vulnerable dependencies, which again, very important, very major cause of CVEs, but they need to be treated very routinely. So now we track them and other community reported bugs in 3 places: upstream, Red Hat, and IBM as needed, as opposed to just downstream. This can result in a whole lot of noise, unfortunately. So we're trying to improve our processes and responses to it. We're working with IBM tooling called VIP Pipeline within ServiceNow to help us get these regular scans into our tracking systems. That should help us verify bugs quicker and more automatically go through these results so that we can get them to the right engineer to fix them. We're also working on moving towards automatic updates when possible. And a major challenge here is that not all dependencies have updates, especially in the case of layered dependency vulnerabilities. So we're trying to manage that while waiting on different teams to upgrade them so that it's as routine as possible. And one key area where Ceph and Rook have focused security is on hardening our architecture. This is arguably more important than the dependency upgrades that I've been discussing because our architecture determines how vulnerable we are. Not, are we affected by some CVE? Do we pull that in? But can this actually be exploited, and can we actually be hacked? So many of you have seen our prior talk that covers security zones, and our general focus is to reduce the attack surface of Ceph to as minimal a surface as possible. We do so to implement secure design principles, and of course, that includes reducing our attack surfaces, but also distributing and isolating critical components. This is Ceph after all. And we started processes such as integrating threat modeling into our development lifecycle, along with regular reviews and audits of our software vulnerabilities. We also regularly now do pen tests. And we share all of this with upstream. Yes, the original reason was compliance with corporate ITSS requirements, but it's important that upstream gets these benefits as well. We also try to support as many other architectural requirements as reasonable, where they improve security, for example, SC Linux, FIPS 140, many more features as options. We continually add options as well as they become relevant to our needs. Some key improvements that we've made over the past few years is having dedicated security professionals who understand the architecture and who target hardening efforts to avoid wasted effort. In terms of code improvements that we've directly supported within Ceph, we've worked with keyring management to ensure expanded secure storage of cryptographic keys. We've worked with Call Home to strengthen the overall security of the Call Home feature at IBM. And we've worked extensively with Dashboard, encouraging a MFA authentication option, work on going on ODIC, and securing Grafana access. So another area that we've been planning improvements on are our encryption changes. Yehuda and Patrick's talk had extensive information about how to rotate keys in CephX, and I'll just say that there's more work in the pipeline for encryption improvements as well. One future goal that I particularly have is to ensure that Ceph implements post-quantum cryptographic standards, perhaps via a messenger rewrite or some other way to get those in there. To that end, I've been talking with IBM Research about open source quantum safe algorithms, and it's probably not a huge risk if we're worrying about these algorithms. We primarily use AES, which is already quantum resistant, but it isn't on the government's official list of approved algorithms for post-quantum encryption. So I'm really excited to keep working with these really excellent teams to make Ceph more secure and very forward-thinking with our encryption. And I'd like to hand this over to Gabriella for threat modeling.
Most of you are probably familiar with what a threat model is, but just to set the stage, at its core, a threat model is a way to identify likely threats to a system and understand where it's most vulnerable. They're important because they don't just tell you what could go wrong, they help teams prioritize risk and guide how to implement defenses. A threat model typically includes identifying assets you want to protect, potential attackers and their methods, and the system's vulnerabilities. It also maps out the possible impact of each threat and guides how to prioritize and implement defenses. In practice, threat models are used to inform design decisions, control implementation, and even incident response planning. Essentially, they're a roadmap for thinking about security proactively rather than just reacting to problems after they occur. With that foundation in mind, we want to give you a glimpse into how we're applying this concept as we build a threat model for Ceph. It's still a work in progress, but here's a rough outline of what that looks like. At a high level, our threat model shows what we're trying to protect, our core assets and components, who might try to attack them, and how. For Ceph, that means looking at assets like data stored in clusters, metadata, and cluster configuration. Potential attackers could be malicious insiders, compromised clients, or external attackers exploiting exposed services. The threats they pose include things like unauthorized data access, data corruption, and denial of service. And the mitigations we're considering include access controls, encryption, and authentication. The idea is to systematically map each threat to the assets it could impact, estimate potential impact, and then prioritize mitigations. Again, this is still a work in progress, but the goal is to create a living document that will continue refining as Ceph evolves and new risks emerge, and one that can guide both our design decisions and incident response strategies. To wrap up, let's review some of the practices we are taking on to advance secure design in Ceph. We make sure bugs are assigned and remediated in a timely manner across all supported versions. This keeps Ceph secure and up to date. We automate scanner workflows where we can. That includes filing and closing issues automatically, which not only reduces repetitive manual work for us, but also helps cut down on scanner noise, as Sage mentioned. So we can focus on the issues that really matter. We also integrate threat modeling directly into our architecture. This helps minimize incident impact and ensures that security decisions are built into the process from the start. And finally, we plan proactively and focus on robust security practices. We design with security in mind from the beginning, prioritizing strong practices over just satisfying scanners. This mindset helps Ceph stay secure, even as threats evolve. Of course, these processes aren't static, and as threats evolve, so will our defenses and the way we work. By continually refining our approach, we stay ahead of vulnerabilities, keep Ceph secure, and ensure that our security practices remain practical and scalable. And with that, we've wrapped up our talk on evolving security needs for Ceph. Thank you all for your time and attention. We hope you've learned something important about our processes and why it's so important to continue evolving to keep Ceph secure. I'd like to take a moment to thank those of you who have supported Sage and me in preparing for our first talk together, and to thank everyone who made this experience so special and memorable. We'd love to hear your questions or thoughts, and we're happy to dive deeper into any part of the process. And if anything comes to mind later, please feel free to reach us by email, and we'll be happy to continue the conversation. Thank you.
Thank you. And if you have any questions, please come on up to the microphone.
Hi. At the moment, or historically, cloud providers that ran Ceph got some early notifications about vulnerabilities that may impact them, particularly on the RGW side. Do you feel that part of the process is still working? How do you want to evolve that?
So we definitely have some upstream CVEs with RGW that we are in the process. We've assigned them to engineers. We're in the fixed process there.
More on the current communication side, where cloud providers did get early notifications in the past.
I'm not entirely sure what example you're talking about. Please feel free to email me. I know about the upstream ones and the scan results that we've had. If there's more than that, please reach out.
Okay, it goes back quite a way, so I'll reach out.
Thank you. Mm-hmm.
So, quick question about security scans during build process. So I've done some work on the upstream build process lately, and I would love to help to integrate some of those scanning tools. Are any of them open source that we might be able to use?
We definitely use some open source ones on GitHub that are there by default. There are certainly some good open source scannings, and I would love to talk about the upstream build process there sometime. Reach out,
Great,
please.
let's do that. Thanks.
Thank you.
Not a question, just a comment. You did a great job. This was amazing. Good job.
Thank you.
Thank you. And of course, if you have any other questions, comments, or want to talk security anytime, reach out. We don't bite. We're friendly. We just want to fix things and sometimes break them. So thank you so much for attending our talk. Let's make Ceph more secure and help it continue to mature and grow as an open source project that has policies and things that sometimes work. Thank you so much for attending. Appreciate it.